Hey math fans, we're on section 2.10.1. Let's get started. This section is called interpreting parameters. And a parameter is a constant in a function that determines the specific graph of the function, but not the type of function. Example 1 says you visit a pick your own apple orchard. There's an entrance fee of $5 plus you pay 50 cents per apple that you pick. Write a function, graph the function, and then it says, what do the parameters represent in the context of the problem? Well, let's write the function first. So I've written f of x, and now we got to think about this here. There's an entrance fee of $5. So no matter what, you're paying the $5, and it doesn't matter how many apples that you buy. And then it's 50 cents per apple, so we'll write that as 0.50, and then that's where we'll place our variable x. So if we buy 10 apples, it'll be the $5 plus 10 times 0.5, 20 apples, $5 plus 20 times 0.5, etc. And here is the graph of the function. As you can see, it's starting at the $5 and it is increasing 50 cents per apple, or in other words, the slope is going to be 0.5 per one apple. It's increasing 50 cents per one apple. So what are the parameters? Well, the parameters are going to be the slope and the y-intercept, because that's going to determine what the function will look like. So the y-intercept is $5. The slope is 0.5. Both the slope and the y-intercept are going to really determine the direction of this function, where it's going to be intercepting the y-axis. Example 2, you deposit $100 into a long-term certificate of deposit, a CD, in which your money will double every 7 years. Write a function to show how much money you will have in total in 7, 14, 21, 28, 35 years. Use an equation to create a table. And then what do the parameters represent in the context of this problem? So let's write the function first. $100 is what we're starting with, times. And this $100 is going to double every 7 years. So we can't just write x, that would be every year. Let's write it as x over 7. So that's going to be every 7 years. And here's a table to help us graph. Again, the intercept's going to be at 100. After 7 years, it will have doubled once to 200. And then in 14 years, that 200 will double again to 400. And here's a graph outlining it. It starts at 100, and then after approximately 7 years, it reaches 200. And then approximately 14 years, it will have reached 400, and it keeps doubling from there. So identify the parameters. So the parameters for an exponential function are going to be your starting point, which is the a, or your initial value. It's also going to be your base. And then, of course, if you're breaking it up over a period of time, remember, sometimes we have the variable and then some factor of t, some sort of time, like every 7 years. So that 7 years is also going to be a parameter. So the parameters are the 100, the base of 2, and then that split up time period every 7 years. And that's going to do it for this section. We'll see you in class.